Well, hello and welcome. My name is James Downey, and I'm from the KubeWise team in the US. And today I have the pleasure of introducing Hubert Heijkers, the Chief Architect of the TM1 Server at IBM. Shortly, I'll pass the mic across to Hubert, and he'll share his views and insights into the future of the TM1 Server, including high availability, containerization, and all of some really exciting innovation in that space. I guess on a personal note, I'm very much looking forward to this presentation, given the innovation and energy that we are seeing, more broadly across the TM1 and planning analytics community. So without further delays, I would like to invite Hubert to begin sharing his insights and thoughts into the future of the TM1 server. So Hubert, over to you, please.
Thank you, James. And thank you, everybody. Hello, everybody. Well, my name is Hubert Heijkers. I'm coming from the Netherlands today, and happy to see people all lining up to hear more about the future of TM1. Let me start by sharing my screen. That'll help and get my presentation going. If it's all okay, you should be seeing my screen right now. All right. So so today I want to talk to you a little bit about and give you a sneak preview a little bit about future TM1 and talk a little bit about what we recently did on TM1 itself and what's coming. I normally ditch these slides from decks and stuff like that, even though I'm legally obliged to actually show them as an IBMer. But today I left them in because there's a whole slew of stuff I'm going to show today that you really have to think about as it's in the lab currently, it's being worked on. There is absolutely no guarantees that it will be exactly the way I'm showing it, even though I'm pretty convinced it will be. But don't take my word for it, and don't presume it is. So with that, as I said, I'll do a quick update for TM1 where we are, and then take you into the future where things are going, and then try and spend quite a bit of my time today in a very little bit techy, but a demo of what's already there in the background. So quick update. So as you may have heard from me, even me tell last year probably, is that we had a big push just before actually this big pandemic on getting the quality up on TM1 server and fix numerous bugs, do stuff, refactor code, get to a continuous environment, etc., etc., etc. And as part of that, we did actually a couple of very good things and brought TM1 in amongst which is the new session management stuff that we did in the server, which got TM1 in a pretty stable state. And so with TM1, with the introduction of TM1 11.8, which was I think June last year, we called it and said this is going to be the long-term service release. This is the version that will support for a bunch of years to come. I've heard dates as end of 2004, end of 2005 at a minimum. But it is the last version of TM1 server effectively as you know it. As I said, it is our most stable version yet. We've seen the proof of that because we had little or no escalation since this version anymore. So the proof is in there. However, people think that we might have stopped working and developing on TM1, and that's not true. So I looked it up, and there was 762 commits going in the last year alone, and we had 6 patch releases during that time. So there's still improvements going in. There's a lot of testing done against it. If there's obviously bugs are being fixed if they're coming in, and we'll continue to do so. So it's not there yet. So this is the version that will be there for a while. Quickly going over a couple of things that we did in there for those that might not have heard about these. We added the capability to do the effectively the top logger into the server itself, so you don't need to run a TM1 top instance somewhere else to create a log. You can do this from in the server right now. We added support for asynchronous TI process execution using a run process TI function, which functions like execute process but runs completely independently. We extended and many stuff which related to the Git integration, the asset management specifically, but improved Git integration for a source code based management of your TM1 models and being able to push those from dev to test to production, etc. Another important improvement at least for us, was the introduction of the crash dump processing utility. If you haven't heard from this, and if you were to experience a crash, this can help you and us tremendously in some cases to be able to get a full dump of the TM1 service to us without sharing any of your data, because this tool will actually remove that from the dump data, which also is a consequence that the size of the dump becomes much smaller because all the data is filtered out. And gives us the ability to do post-mortem analysis on any instances. We added support for HTTP proxies and SSH for the Git integration for those customers that use it. Plus, out of the box, we're providing now all the standard certificate authority keys. So you don't have to register keys anymore for your favorite GitHub or Gitbucket or whatever that you're using TM1 with. Course improvements, it's all around cross-origin resource sharing. Effectively, the main difference here being we already supported effectively the protocol, but we didn't allow you to limit the sources, the origins from which to accept scripts that were talking to TM1. And now with the whitelist, which you can define using the HTTP origin whitelist configuration, you can now limit that to on top of that. We added some resilience against what I call DDoS attacks. We had a client that created tens, if not hundreds of thousands of requests for one session to the TM1 server, effectively bringing it to its knees. And so that's no longer possible there either. And we added some, effectively missing TI functions. This is just a couple of things that we did in the 11.8 branch, just to show that whilst we said it's a long-term service release, there is still work going on. So that's for the existing TM1. But people that have heard me talk about future, they've heard me talk about a bunch of things in the past already. And I think everybody that follows a little bit, IBM knows that IBM is all in on hybrid cloud and AI. We're the hybrid cloud and AI company, right? Effectively. And obviously that has its, that's the strategic direction of the company. And obviously that strategic direction, translates in things for specific products. So what does it mean? What does this mean for us? What changes does that imply for TM1? Well, first and foremost, right, the future is cloud. So TM1 needed to be containerized. So containerization, right? Developing for the cloud with a cloud focus and effectively, almost cloud only. And being able to, get to a world where we can continuously deliver newer and better versions of the product with a guaranteed quality level, right? So where are we delivering? Well, IBM hybrid cloud infrastructure, meaning, cloud packs, right? Cloud packs which people can install on-prem, but also cloud packs as a service on IBM Cloud or even other clouds, right? They're already available as far as I know on AWS, and it's either already on Azure or coming on Azure shortly as well, right? So what's the impact? What directly are going to see about that in TM1 12, right? So TM1 12, we've been working on this for a while, right? So you might have heard me in the past talk about a project called Exciter. That was, what led into a lot of these things where we started to toy with technology and, building effectively a completely from scratch new infrastructure in the background, which was oriented on containerization for cloud to get to a enterprise class cloud ready product, right? The main features that it had to have, obviously, was apart from being able to run in such an environment, it needed to be highly available with failover. And what that means is that you can actually run it in an orchestrated environment, and the service itself will coordinate across multiple nodes that are running for a TM1 instance. Route requests, and if one goes down, so if one crashes, the other ones will simply pick up the work and the slack. And apart from the failing request, obviously, the service will continue to be available. Hopefully 100% of the time. We know it's not going to be 100%, but 99 with a lot of nines, hopefully. What that also provides is us being able to scale that way, is that we'll be able to deal with more load. More load meaning we can run the same database on multiple instances. The infrastructure itself already makes sure that all these instances keep in sync, and therefore we can have more people hitting the system, and therefore share the load across more nodes. So in peak periods, customers could then choose to actually run more instances of the same model, and in slower periods, take some of those instances away again. I've put it here, new modern global memory allocator, because it's being talked about by our product management as well. And so we did make a big step forward there. We did rewrite the underpinning of our memory management. So yes, ultimately, most of the memory is going to be freed up and released back to the OS. It's not instantaneously, but it will do that. So effectively, even though garbage memory was never the technically correct term, we kept it in memory cache. But there is no garbage memory anymore. At the end of the day, the system will gradually release all the no longer used memory back to the OS. The only thing I want to add to that is that the peak memory usage is not changing. So unfortunately, unlike in the keynote at the beginning of the conference, somebody implied that if you have one server that used a lot of memory, you can now have 3 instances that use less. That's technically not correct. If you have a system under load, all of these instances would still use as much memory at their peak usage. And that's not going to change. What more are we doing? We are in multiple steps, and the first step will be in the first version of TM1 12. We are working on Mdx Maturization is what I called it here, because that's where the first focus is on. Mdx has been for a long time the query language that can be used in TM1 for dynamic subsets, but also to query the data in the system. We're tightening it up, making it faster, at the same time less ambiguous, and making more improvements there, up to a point where we're actually replacing, and that will be the second step, replacing the Mdx execution engine and the parser with a new one, which is based on a technology that's being used within Cognos and known as LOLAP, which we completely took and refactored into for use in TM1. And then the third step is going to be that we're going to replace our aggregation engine as well, which will be feederless. And so I'm answering the question that I got earlier already today. Is that still ongoing? Yes, that's still ongoing. That's the third step in that maturation step, where we're modernizing our whole query technology stack. Moving to the cloud obviously implies that things are in a different place. You don't necessarily have access to things like a file system or something like that anymore, right? So nor is can you simply control the environment TM1 runs in, because TM1 itself now runs into a container, and you your environment you normally ran your TM1 server in is no longer there. So things like execute process to run something locally on the TM1 server doesn't necessarily work anymore, because whatever you were trying to run doesn't exist in that environment. So to offset that and to make TM1 again more open, we're extending TI to allowing it to make web requests effectively, relatively generic web requests, so that you can call effectively any service, and whatever it returns is, you get back as a string in TI, and you can do what you want with that. But at the same time, obviously, you could use a web request to send an email. If you have a service that does that for you with the right URL, you can actually ask that service then to send an email to somebody. And obviously, the application is limitless, right? What you can do then, you can start daisy chaining stuff. Also, because of this file orientation, right? We extended what we already had as content management in our RESTful APIs in a way that you are now allowed to manage a set of quote files, content, that's still going to be files locally in the container for TM1 through the REST API as well as a content endpoint. At the same time, so this could be things like your CSV files that you're loading through our TI process, right? But at the same time, we extended TI again to say, okay, instead of having to have that file local, TI can now reach out to a resource anywhere on the internet effectively, as long as you can provide us with a URL to retrieve that file. We can load from that file directly. We will actually retrieve it and consume that in there. And the idea is that before we're done with 12.0, we can actually do the same thing for processing the output of a TI, instead of writing that to a local file to actually put that somewhere on a resource. So you get OpenML. And in my demo later on, I'll show you another case of where we are actually allowing to pull and push to an external resource. I'll remind it there. Odbc obviously is typically the other resource that source that people use to load data into a TM1 model, right? So Odbc data and CSV files are typically the most two common cases. And Odbc obviously is something that doesn't necessarily fit into a container strategy in a container environment either. So what we did there is we externalized this. Obviously, TM1 11 since a certain version already was using a proxy process to run Odbc and didn't run Odbc in TM1 anyway. Now we opened up the communication effectively between these two and created a new proxy or a new service effectively that then serves those Odbc endpoints, which means that you can install that service anywhere where you have your Odbc drivers. And then TM1 will connect to that service, you specifying the URL again, right, where that service is, and it will pull that data from that service. Or if you're using your Odbc connection to push stuff, to send queries, to update information or whatever you want, that will go to that service as well as a request. The way we did this in obviously TM1 style is by defining an OData compliant REST APIs for this service, which means that whilst for us, this was a replacement for the Odbc connectivity that we had in TM1 11, anybody out there can now implement that same very straightforward and relatively simple REST API specification for his or her own data source. And we don't care what it is. So somebody's already proposed to do a Java-based JDBC implementation for this, and so that TM1 going forward could pull from there. But theoretically, anything that you can represent as a relational data source, you could make available through this service as well. It doesn't need to be Odbc anymore. So in that way, it's become a new extension point for TM1 as well. What else is changing? There's more stuff, right? So we did go ahead, since nobody has direct access to files anymore anyway, and since we've decided that going forward, we want to have full version history of any and every change in the TM1 server, which we didn't have in the past, we have moved to a new format for our metadata, which is aligned with and looks very much like our the format we're using for a Git integration. Actually, the Git integration in TM111 is actually came from the work we did in the Exciter project for this new metadata format. So it's actually the other way around. We are storing those that metadata in a Git repository for exactly that purpose, so that we actually have a full version history. So in theory, we can go back to any version for as long as we're keeping history in the service. But the infrastructure in the cloud is different as well, right? So whereas you had log files, typically the message log, most notably, in TM1 as you know it, in a service-oriented world, you have to look at to whom the logs are, which purpose the log messages serve, and therefore where they go. So generically, log messages for operating a service are going in a centralized logging infrastructure, and in IBM Cloud that means log DNA. In the CP4D, Cloud Pack for Data, that means log stash, because they're using the ELK infrastructure there. And so those we support out of the box, and we support the standard out way of sending out messages as well in this infrastructure, so that they could be collected in your favorite Kubernetes environment if you had the ability to run it somewhere else. Transaction logs we're actually keeping have always been crucial, by the way, for TM1, right? Because that's what you needed if you wanted to recover from this catastrophic event in TM1. But they were still optional transaction logs. They're no longer, we're under the covers keeping them. And they serve two purposes in TM1 now and TM112, because if we have multiple instances of TM1, that's how we push our changes in the model from one instance of the model to another instance. And I'll show a little bit how that it looks like in the background later. And for that, we actually choose to use a MongoDB database, so we can be sure about certain transaction logic and synchronization between our instances, and keep our whole high available cluster up to date and in sync. But the biggest change, maybe, other than all the other environmental changes that moving to the cloud brings you, is that we are going to be REST API only. That's not because we want to. It's also because the old APIs simply can't work in a cloudified environment where you could fail over to different instances and stuff like that, just by the sheer design. Apart from the fact that those APIs never performed over the internet to begin with. So what that means is that all your traditional clients, so everything effectively that wasn't written on the REST API, no longer will be supported with TM112. So most notably, obviously, architect perspectives, but also if you still have performance model or Cognos Desktop, will no longer be working. A little bit of an overview. Don't read too much into this. I just want to give you a high-level idea to place a little bit all the components I touched on. You see the center box in black with the black square, right? That's effectively an installation. In this case, we use Planning Analytics Workspace as the consumer of TM1 as a service here. In the background, you see on the top the Planning Analytics Workspace service on the top, and then the darker gray box, which has everything that makes up TM1 as a service, where in that box made a distinction again between the TM1 service and TM1 databases. So we're not talking about a TM1 server in traditional sense is a database in this new model. And then there is a service portion that manages effectively this whole infrastructure. So if you had a CP4D or later on IBM Cloud and TM1 service, that service would be always there and always up. And even if there's no database, that's where you go to ask it to create a database for you, scale that database, do stuff with the database, you know, backup, restore, do the normal things that you would want to do with the database, but all through a RESTful API. On the bottom end, you see those two NFS volumes, one for each of the databases. And this picture, the way it's drawn here, one database has two replicas, and the one on the right and the database on the left has three replicas. And those replicas, share a volume or a persistent volume claim, as they're called in cloud speak. And so I mentioned the Odbc service, right? We call it the Odbc integration service, and you would install that wherever you have your Odbc drivers. Well, that's why it's on the left, on the global internet somewhere, right? We can call to that. These external endpoints are for web requests, right? If you want to know what the current, stock prices of your favorite stock, or you want to have stock price for a set of stocks or something like that, because you're updating your TI database, TM1 database, you can get that information through those web requests, for example, in external endpoints. And on the other end are the stuff that we're using that has to be available in that environment. The TM1 service is installed in, but TM1 doesn't run itself, right? So the integration with the logging infrastructure and the Mongo database that would be running there. So again, just a high level picture. You don't have to be able to know all the parts after this. And one more thing I might add is the service. As you see, it has 5 of the blocks in there. I think there will be eventually 7 or 8 to start with. You see gateway, authorization, async handler, batch handler, TM1 daemon. These are also all microservices that together make up the TM1 service, and each of those, at least we're running in the environments. You'll see me demo in a minute as well. We'll run 2 or 3 instances of all of those, so those are all highly available and redundant in the cloud environment. Again, to make the whole system highly available and be resilient against issues. So with that, seeing is believing. Let me continue on a demo, right? I'll go to a demo. So quickly, the scenario, if you were here last year, you saw me focus on initially grabbing a Pony Music model from courtesy to Cubewise. And that we did a project around, and you defined a project description, and then we created a Git repository for it, and then pushed it up there. And then I showed already, with what we had back there, how that could then be consumed. This year, I still have that repository around. I cleaned it up the repository up a little bit, but you wouldn't notice it. And I'm going to use that and deploy that in 2 cloud environments. Actually, we're running in. I'm going to use let's call it the development and the production environment, because that's how I happen to name those environments. But I have 2 environments, which I'll use later on to show you how we actually support backup and restore. And the restore for disaster recovery. So how do I quickly get stuff back up there? So I'm going to deploy it in the cloud, showing it running there, highly available, etc. So taking you through the steps that are, I think, interesting in the context of this demo. So let me switch. So this, now it gets technical. I'm going to switch to, in my case, Visual Studio Code. Actually, I should switch to my cloud environment first. So I'm running on IBM Cloud. And on my IBM Cloud, I have had for a long time, my team has had for a long time, 2 clusters, which we call Exciter Dev is the one, and the other one is TM1 Dev OS. This is a IBM Container Services cluster, and this is an OpenShift cluster. The difference being, one is OpenShift, the other is vanilla Kubernetes effectively, but they're both effectively distros of Kubernetes, right? But then the Red Hat flavor, right? OpenShift, Red Hat OpenShift, and the other one is the vanilla one. Just to go in here, I'm just going to open both of them up by opening up the Kubernetes dashboard for my IKS cluster, and I'm going back to the, open up the other one. So I have both available. Oh, that should not have taken that long. OpenShift Web Console, but it works. So I've got my, if you've ever worked with Kubernetes, you know this one, right? So I'm going to switch, in that case, they're called namespaces in Kubernetes. I'm going to switch to my TM1 namespace. And I can see that in my TM1 namespace, I currently have a bunch of pods running. And if you remember the architecture overview I showed you just now, you'll see my daemon, my batch handlers, my authorization, my async, and you see 3 of all of them. And there's more, right? So this is the first time I have 15. And so there's more daemons and gateways. So each of those microservices that were in that picture, I have 3 instances from, just to make sure that if for whatever reason one goes down, I have another one. Secondly, within IBM, eventually we'll deploy on multi-zone regions, which means there is multiple data centers that make up one region. And so we'll make sure that we have at least 1, probably even 2 in each of the zones. So you'd end up with 6 logically in the cluster, but they still run in different centers. Anyway, that's just all scaling related stuff. You normally wouldn't have to worry about that. It just helps us being highly available there. Similar on our OpenShift cluster. In that case, it's called projects, and then on projects we have. I'm going to choose. It's not called namespaces, but it's in the day it's exactly the same thing. I'm going to switch to TM1 there as well, and I see that I have also 15 pods running. Those same 15 pods, so the same service. Basic services deployed on both these clusters. Now, none of these, as you can see, these are just the 5 services that together make up the TM1 service, but there are no databases running here. So now I'll go to my my Visual Studio environment, and which I use to do REST requests using the REST API. So to show it first is that I have configured in here, first I have 2 environments configured. So if you Ctrl+Shift-E, you'll see I have a development environment and a production environment. This is Visual Studio Code. I can name these whatever I want. It's just to quickly switch between sets of settings, right? So if I choose development, I'm talking to my Exciter dev environment on Montreal 1 Containers App Domain Cloud, which is IBM Cloud. And if I choose my production environment, I'll be using TM1 Dev OS. That's my OpenShift cluster, also running in Montreal Containers App Domain Cloud, right? And I have these deployments have root credentials. You can see them here now. Obviously, you don't want to share these, and these are actually stored. Normally, you wouldn't necessarily externalize these because these are stored in secrets in these clusters. And I'm God in this cluster, so I can see these, right? So these are actually stored here, or I can copy them here. So reveal values, here you can see them, right? But you have to be, an operator or an admin in this system to be able to ever get to these, right? So I, for convenience, just grab those because I'm running something outside that I want to do. Typically, you would not use these credentials with anything. Let me shut this down here quickly. With anything outside, running outside of the cluster. So I'm cheating a little bit. But that's where they come from. So each of those clusters after deployment get a unique set of credentials generated, right? Every deployment gets new ones, by the way, they're seriously unique. And this is what I use to get, in at the root level of the service. So if I go to my demo script, right? If I now, so at the root of every service, and I'm an OData evangelist, right? I'm a member of the founding member of the OData committee. So every service in TM1, also these new extensions at the root, is all service composition, and all of these services have OData compliant APIs. So every one of them, you can actually question the definition of the API, right? So what the root tells you is something like I can have things like instances predominantly. Oops, I shouldn't click, right? Instances. So I can query those instances and there are currently none, right? So I'm going to create one. And so in my configuration, let me go back here. I said that I'm going to use as an instance name. That is very annoying. The instance name is, where's my instance name? Oh yeah, Horizon 2021, right? That's the one I'm going to use. So if I call a post send request, you see how quick it is. I have a Horizon 2021 instance. What logically now happens is that I have an instance of my service in TM1. And within that instance, I can define things like applications and databases logically. So I'm going to create, it's a new instance, so it has no applications, right? So I'm going to create a Horizon demo application. This is important because I need these credentials. So I'm going to quickly copy these over here so I can refer to them in the rest of my script. And what's important to copy this one because this one you only see on the first request. Typically, if everything runs in a cluster environment, you'd store this as a secret again in the cluster so nobody could ever get their hands on them again. But again, I'm using this from outside the cluster. So the next thing I would need to do, and the first time, is to create a database. So I'm going to create my Pony Music database now. Now I'm going to send this request. And I'm going to look at, so I'm using the development environment. And so what you'll see is that here now, as you can see, a new pod popped up. It created 4 seconds, 5 seconds ago. That's the pod that's going to actually run a TM1 server service, effectively the database service, right? Kind of the TM1 server as you know it today, but it's, it has obviously way less in there because it's purely the database portion of it that we're starting up. Now, this takes about 3 minutes, so I'm going to have to talk over this one for a little bit because the reason that is because now we effectively sent a message to Ibm Cloud and said, Ibm Cloud, I need a disk from you, storage, 20 gigabytes. I didn't really ask for any specifics, but I know that we set the IOPS, the amount of operations to, I think, just 1,000 per second or something, quite low. But I need disk space, and provisioning that disk space takes the majority of those 3 minutes. I think it's 20 seconds for the whole deployment otherwise, and it's 2.5 minutes to get that disk space for that. So if you have a question, James, then yeah, shoot.
Yeah, I appreciate that. And thanks, Hubert. There's a few questions coming through. I guess one of the questions that is just jumped up is, does this mean that TM112 will not be available on premises? can only be installed in the cloud. So I think that kind of a definition of what is Cloud Pak for data and how can that be deployed. You want to share some thoughts there, please?
So the official story is indeed that TM112 would only be available, obviously, as part of the planning analytics service, right? So including POL and PA and whatever is in there, right? We would be one of the services that comes with that service when you on either CP4D, a future version of CP4D, and CP-DAS, which is Cloud Pak for Data as a Service, which is effectively running CPD but on cloud. And CP-DAS obviously doesn't have PA in there yet, that version, but is already on IBM Cloud, but also on Amazon on AWS, for example, right? So that exists already. So yes, that is it. Purely technically, right? If you had the set of containers, and and I'm not a licensing or legal or anything kind of guy, but in TM1 itself, the set of containers I'm running here, any container environment, any Kubernetes environment would do, right? So you can run them on any container service.
Windows, Linux?
No, Windows is, that's not the container service, right? So they are Linux containers. So it would have to be a Linux, environment. We are only developing for Linux as it is right now. That's the official story. Okay, we internally still have a standalone installable version on Windows. Ironically enough, it doesn't do high availability in the sense of you have multiple instances, but it does fail over. So it crashes, it auto restarts and everything. But as far as I know, there's no plans to ever release that, because it doesn't fit with such. Again, if people feel strongly about that, talk to your salespeople and and product management, because at the end of the day, they are the people. I have no say in any of that.
Another question that came through, this may be a two-part question, is do you have a ballpark like ETA on TM112? And I guess the other kind of second part of that question is, I think there's a lot of new concepts here that are being introduced for TM1 developers, microservices, OpenShift, Kubernetes, things like that. What's your kind of advice to for TM1 developers out there to kind of get a head start on some of these new concepts from a learning perspective? So
I think the good news partly is that the core. So it depends on what you use as what kind of developer we're talking about here. If you're developing in the model in in Arc, for example, right? Then apart from Cubase code having to do a tiny bit of work to set up the connection, the REST API are not there from once you reach that database is the same as it was for 11, and it'll work, right? The fact that we store it completely different under the covers and that a whole slew of things work differently under the covers is completely opaque to the consumer at that point. So that's that part. Again, once the service is up and running in Cloud Pak for Data or CP-DAS, the REST API, as I just did, is the only thing you need to know about. Everything else is orchestrated for you. You would never, ever have to do any of that.
So maybe with that in mind, for people kind of looking to do some additional learning to kind of get ready for some of these changes, it's to kind of send that learnings around REST API.
So personally, right, the whole world is going container, right? Containers, right? This is how you deliver software going forward, period, right? So understanding how a Kubernetes-based environment works it always helps, obviously. If you as a developer are very interested in this kind of stuff, but from a TM1 perspective, you don't need to know it necessarily, right? Once the environment is up and running, you just talk through the REST API to it. You would never ever have to look. You would never have to look at any of this, what I'm doing and showing here. That's up and there.
Okay, great.
For some reason, we have a bad day today because it takes 5 minutes already, and it's never taken 5 minutes for me thus far. So it's either busy or whatever to get those disks provisioned. which is a little bit unfortunate, but
Maybe another question for you, if you don't mind. This one's a good one.
Go.
How does high availability failover work with TM1 being in memory? You able to kind of share some thoughts on that?
Why do you think it took us quite a while to get here? So we are actually starting multiple instances of these. Let's see. Oh, it actually did come back. That's weird. The state. Oh, now it comes. Okay, I should have expected. So it did come back. So how does that work? Well, let me show you. Give me 2 minutes and I'll get back to this question. Right. I wish I could. I found a way to actually shut Slack completely off. So now that I have a completely empty database, and to quickly show you that, a little bit further on. No, sorry, lost one step. So you saw me copy this application ID and secret that I just did, right? So in a cloud environment, right, the service, in this case TM1, is not the service you authenticate with typically, right? You are authorized to use it or not, and in TM1 having obviously its own security, and that hasn't changed, so we need to know who the user is. But authentication has happened earlier. So in that picture that I was drawing, right, I had Paul at the top, right? So if you presumably Paul would have authenticated you already, but Paul actually doesn't authenticate you in a Cloud Pak for Data environment, because you would already have been authenticated when you came into Cloud Pak for Data. And when you clicked Paul, right, Paul only was told who you are because you were already authenticated, right? And so what I'm going to mimic here is that I created this Horizon demo application, right? And this Horizon demo application thereby is trusted by the service. That's why I gave it a client ID and a secret. And using that client ID and secret, it can then subsequently ask for a session for such a user. And this /auth/v1 follows somewhat the Open ID standard for authentication endpoints when you're progressing with tokens. So in this case, I'm going to tell it that I'm Hubert Heijkers at nl.ibm.com. That's my subject ID. That's what I was used to authenticate into this environment. And then it just asks effectively, and you see it immediately comes back with a TM1 session ID. This is exactly the same again as what you would have had in TM1 had you authenticated with a TM1 service, right? So once this cookie is there, from here on into the database is exactly the same effectively as it was in TM1 11. So I can show you that, because if we can get the metadata, you will actually, I did hit that, right? Yeah, there is. So it is still TM1 API v1. Version is the same. It's a later version, but it was added in 10.2. So there's stuff deprecated in here that's not the same anymore, stuff like that. But at the higher level, it is the same, right? So and just to quickly show, this is an empty model. I'm going to exclude control objects, but get the list of cubes, and you'll see I have an empty list. So I'll quickly grab my Pony Music model from using Git. So to that, I do a Git init. These are the exact same requests as you would use. Oh, sorry, I have to do Git init first. Git init, initialize it, bind it with my github.com, Hubert Heijkers TM1 model Pony Music. So if anybody wants to, will have a look at that at public GitHub, you can. That's the URL. And create a pull plan. This is the things it's going to do. It's going to copy some files. It's going to create some dimensions, create a couple of cubes, create some processes, and execute a couple of tasks. And when I execute that, which is relatively quick, typically 1.7 seconds, and I have my Pony Music model running. And so now if I ask again which cubes I have those 3 cubes with their dimensions in there, and the data is loaded, and everything's in there already. So very quick, everything's up, right? My model is there again. So this time I'm not going to use that model, because we did that last year and shown that that works and stuff. But what I can do is say, okay, now I want to scale, to get back to that previous question, right? I want to scale my model to 3 replicas, and I can just do that by saying replicas 3. So I send the request, to do that. But before I do that, because I had an issue with this earlier today, and so just to preempt that, because there's one other thing I desperately want to show, I'm going to first take a backup, right? And to show how one other integration, I'm going to show that I actually created a MinIO, which is an S3 compatible storage, and MinIO Horizon .heijkers.net, which is my own personal domain, but it's actually running on Digital Ocean, which is another cloud provider. MinIO, very secure storage. And in here, I created one bucket, which is called TM1 backup sets. There's nothing in there yet. It's empty, right? Just to show you that. So what I want to do is ask TM1, I'm going to skip a couple of steps here. So it's an S3 compatible storage. And so S3, I'm actually using the AWS pre-sign script to sign a URL that allows me to get to MinIO Horizon, my MinIO instance, right? To allow it to use the TM1 backup sets bucket and to create a TM1 of the Pony Music TGZ file. That's going to be the object I'm going to store there. And I say store, it's a put, right? And then obviously I have to give it my username and password, which has the very secret MinIO storage. And I asked it to expire in 48 hours. In this particular case. So I did this in preparation last night, so I don't have to do this script again. This is the URL it then generates. And so that's the URL I'm going to pass to backup. So I'm going to post a backup request to the database we just created. So send request. It takes 2.3 seconds to create a backup of this. Obviously, it's a tiny model, right? But the 2.3 seconds was to go up from, I'm here in the Netherlands, to Montreal to store the backup, to create a backup from the TM1 model. So it doesn't save data all if it needs saving and stuff like that, right? And stores everything that wasn't stored, package that, zips that up, and then stores that, in this case, on a Digital Ocean S3 compatible storage in Amsterdam, halfway across the world again, and does all that, and then reports back that that's succeeded, reports back to me here that it succeeded in 2.3 seconds. If I can go to my console here, you'll see that I now have here a Pony Music file. And I actually can download this locally as well and look at what's in there. Actually, maybe that's funny. Let's see, open, show in folder. Oh, no, that doesn't work. Open with 7-zip. And you'll see there's a tar in there. It always starts with dot, that's by convention. And then you see the files in it. So there's still cups. They're not compatible with the cup format of the old ones. There's my CSV file that I had in my repository. Apparently something went somewhere wrong because I had process errors in here as well. I've got my cups, feeders, and then there's other files. So all the stuff is in there. And you see me as a user even. There is a user folder in there, which should have started with a curly brace, I think. But okay, that besides. You see, it creates a backup. It's a real backup of what we have here, right? And even the Git repository. Oh, sorry, the Git repository with metadata and all the stuff is in there too, right? My cubes, definitions, my everything in JSON, everything is there. So with that, I'm going to quickly make a switch to my production environment, which is my OpenShift cluster, right? And I'm going to ask the same thing of my OpenShift cluster, but I'm going to zip through this because I'm running out of time otherwise in 5 minutes. So you'll see my instance is empty, so I'm creating an instance. I'm creating the application, which I then quickly have to copy those two credential settings for. And I'm going to ask this one as well to create my database. And then in a second, I'm going to restore the database from the backup set coming from that S3 storage on that other cluster. So this is my disaster recovery, right? So because you don't want to store it somewhere near to where your service runs, I moved it from Montreal to the Netherlands, right? The backup set. And I'm going to pull from the Netherlands again into a different cluster, to restore this, to mimic a disaster recovery effectively. The only thing is, again, the 3 minutes or whatever it's going to take to start up this. Then while we wait for that to complete, I'm going back to that scaling now. So if I'm back to my development environment we were just running in, right? Which just to quickly show, I do have the cubes here, right? So I'm going to send this request. So I'm going to, what am I doing here? So this is the URL. It's the URL to my Pony Music database, right? And I'm going to ask it to increase the number of replicas from 1 to 3. So I'm just going to send that request. And then I'm going to switch back to my console here. And you'll see that here, 2 new containers pop up, right? We do all the orchestration. So this is actually the daemon service that does that. It's coordinating this together with Kubernetes, right? And orchestrating that there is 2 new containers started. These containers are going to start the service. They don't need to, there's nothing to do with the persistent volume claim because that exists. So they're initializing. As soon as they're initialized, they're going to start TM1, the actual process, and then they'll very quickly get up to date with where the leader, in this case, the existing, this can't only be the existing container, but there was only one, that's the leader, is. This might take a minute or two, but then you have 3 nodes running in this environment that are all representing that same database. And from that point onwards, if I send a query just for information from this database, it might go to any of the 3, right? And if one of those services drops, it'll just switch to using the other ones. And the second one of them drops, by the way, the whole mechanism works in a way anyway that no new requests will be routed there. They automatically all go to the other ones. But on top of that, it will automatically start a new one where the same as here, it'll start up, it'll get up in sync, and it'll add itself to the list of available replicas. Even if all of them go down at some point, they will be restarted, all of them. One will become the leader again, and a couple of seconds later, the service is up and running again.
And so that would mean, and we're just running a bit short on time here, so that would mean that if I was an end user, as an example, in a workspace environment, and I can kind of send, I'll send the request to the TM1 server, and it will just kind of work out where to get the data from those replicas, if I'm understanding that.
Yeah. So you see running now, right? So now I got the response. If I now grab the information about the databases, this is the response from my OpenShift cluster. I had 2 requests running, but if I do get databases here, you'll see that I have, there's 2 still starting. Okay, the containers are running now. Now they're catching up. So give it another minute, and then it's slow tonight. But they get in sync. You'll see that all have the same version. I'm going to quickly switch back, if I still have a minute, to my production environment. Run that same process. Ask for my databases. Hold on.
I think we have literally a minute.
Literally a minute. That's why is this not? I'm using the wrong one. Hold on. This one sent. It is up. Okay, now I have my database up, so I can now say call a restore on this empty database. This is my OpenShift cluster, and so I can just call restore on that one. It says, oh yeah, I did not create my session. Where's my username? Oh, send request. There it is. I am an admin, so I should now be able to restore. That should take a couple of seconds. There is no content. This takes a little bit longer because it means it's done. It has retrieved the backup set. It has put it there, stuff like that. But it's like a restart of that instance. So it's disaster recovery, right? So you have a tiny moment of downtime. It does that restart. But yeah, shortly here, same thing. If I go to my pods here, you'll see that I have a database running here. It is already running. It might not be in the running state yet, but shortly you'll be able to use it, and Pony Music will be running on my OpenShift cluster now. Having pulled the backup set that I pushed up to Amsterdam, right, to my MinIO object storage and pulled it back.
That's great.
All right, that's all the time I have. I had more stuff prepared to show, and honestly, that's only I'm purely focusing on some new stuff. There's more new stuff actually than what I touched on, but and then obviously all the existing stuff is still there too. But just showing purely focusing on TM1 as a service here, what is in a future version of it.
Excellent. That was very informative, and I think it was excellent to see some of those slides around TM1 12 and just seeing, as you were kind of showing some of those kind of techniques there with the S3 and the DigitalOcean kind of as replicas and things like that. It was quite nice to see. Please, yeah.
No, sorry, yeah, I had this one more slide, but never mind. I think I mentioned this anyway. Never mind. Yes, yeah, and so it's not just that S3 compatible. We did get put any HTTP based or S3 compatible there to begin with. But we're trying to extend, apart from the REST API, which opened up TM1, we're trying to, in and out wherever it is, to, be more resource oriented, as opposed to what it was with, where it was, file stuff. But when it's resource based, it can be either which place. So eventually, I'm even contemplating having TI processes that can have input from a request. So then you really can become, TM1 can be really part of a service mesh, right? Currently, it can't take input from a mesh, but it can be the target of stuff. You can actually with what we're having in TM1 12.0, you can actually run a process, right, and have information grab. If the TM1 server you're pinging effectively, right, you're sending a request to, returns you something in CSV format, the other servers can actually live load it. You don't need a file or anything in between anymore. Okay. It's that open, right? So and the sky's the limit. There's more and more opportunity there.
That's great. Yeah, as you can see, there's quite a lot of kind of extra innovation that's coming through these releases. So really looking forward to kind of seeing this in the months and quarters ahead.